multimeter there is reading a voltage across a 1 ohm resistor. So we'll set up.
Yes.
Okay.
Yes.
So if it, let's say that reads 1. All right. 1 volt is what that reads. All right. How much current is going into the magnet?
It's 1 amp.
1 amp. Okay. So how many? What's the field then?
It'll be 395.25 gauss.
Great.
It's easy math there.
All right. You were lucky this time. All right. So I'll put that in here. 395.25. All right. Now, if we went, let's say we switched over to the 10 ohm resistor, what would this number be then?
Well, then it'll be 1/10 that.
Okay.
Yeah.
So it'll be 39 points.
Yeah, you should go to graduate school.
Thinking about it now.
All right. So, all right. And then add, if we wanted to add something. So if there's a little offset or something, we would put that in.
Okay.
We'll add 0 for that. So we'll update that. Okay. So that gives us, here's our temperature as our first channel. This is our field in Gauss, our second channel. The third channel is going to be our resistance reading. But what it multiplies by and what it adds into is going to depend on the bridge settings and stuff like that. So typically, you have the bridge balance at some resistance. So that's going to be the add, right? So you balance it at 20 ohms, whatever. So add will be 20 ohms. And then we got to figure out, depending on what sensitivity you're on, that'll give us some given voltage. We have to figure out what resistance that voltage converts to. All right. So that's going to depend on, once you balance things, we're going to fill those in.
Did you explain that we need somehow set up this synthesizer or this catalytic gate controller? That,
yeah, I mentioned that while you were away. So this is after you edit GPIB file. There's gate control and synthesizer control instruments that are controlling the Keithley voltage source and the HP synthesizer source. So the gate control instrument is actually already set up automatically to gate control. So when we give the computer a command to say change the gate voltage, it will change the Keithley, which will change the current going through our magnet, so which will change the field. And then let's go back to our data input file. So we have 3 things in there. The fourth one I'm going to I don't want any more besides the first 3, so I'm going to choose input instrument none to delete this line, and then it's going to erase this Tableau file. So that's fine. Change everything. So now I have 3 things. I just have 3 things in here, and over here it actually lists them: temperature, whatever names they give them, temperature, field, and this one doesn't have a name. This one is this name voltage, but we'll rename it depending on the resistance you're measuring it. Okay. And then you want to edit what plot you're taking. So this is going to take, when we start to run. There's one other thing that's important actually in this data input file. So when we start to run, this is just going to start reading all these things, and it'll just continually read them. But the question is, well, when does it actually take a data point? I mean, it can just take a stream of data points based on time. You can set it up that way if you want. Or every time the field changes by a Gauss, it could take a data point. Or every time the temperature changes by 10 millikelvin for the data. So we can select which channel we want to bin these data points. It's going to be continuing collecting these data points, and then we'll that channel will change, will increase another 10 millikelvin, or the field will sweep up another Gauss, and then it'll average together all those points it's taken and record that data point. Okay. So in our case, we want the bin channel to be on the field Gauss. So that's channel 2, the second one, the Gauss. And that then it says it's averaging over that field. And then it'll when we start actually doing a run, you'll see it'll count up how many data points it takes, and then things like that. But we need to select that. Then it's going to be continually taking these data points now, and we want to graph, whatever it is we're measuring. So in our case, so we'll go to edit plot file, and I can have a different number of different plots. Right now there are 2 plots selected, but I just want one plot, and I'm going to plot, let's say, I want to plot field being my x-axis, and I don't know, maybe we're going from minus a kilogauss to plus a kilogauss. And whenever you put these numbers in, you have to press enter or return, otherwise it won't remember them.
Okay.
And then this was going to be a resistance channel. We're going to change the name of it, but and maybe resistance is not going to be very much. It's probably going to go from, let's say, 20 to 21 ohms. And then update the plot file, and then now we have field down here going from -1,000 to +1,000. This channel going from 20 to 21. And we can add another plot if we wanted to, but one plot's enough. And then we need to go set up our instruments now and things. But then when I go to start run, it's going to start taking the data. So if I get a start run right now, so it's reading the temperature off, which is good. The field is just sort of fluctuating. This is just small voltage fluctuations. And then who knows what that's reading over there now, or what that's multiplying by, because we haven't set that up.
Yeah.
So this is the number of data points it's taking. So roughly every second it's taking these points, but it hasn't yet averaged them all together to form an actual data point. So it would do so when the field reached some value. All right. And since the field is static right now, it's not moving, we're never going to reach that value. But when it did, it would record 1 there, and this would be set when counted again. All right. So stop on here. The way to set up, so the next question is, well, how do I set up, like, do I want it to average over every 1 Gauss or every 5 Gauss, whatever? And the way to set that up is through the run program. So I got to edit run program. And this is what a run program looks like. There's just some lines of code here, and the code is deciphered on this guy on the right. The most important code, the one thing you always need in anything, is this X command. It's the first command, which is the bin spacing, which is exactly that. So if I want every 1 Gauss to take a point, every 10 Gauss to take a point, whatever, that's what I put in there. So the X bin spacing set number in units of the X channel, which is the binning channel. So my program is going to be the minimal program I can have is X, and then if I want to do it every Gauss, say 0.1, I'll put X1. It'll give me 1 Gauss. If I want to do it every 5 Gauss, I'll put X5. If I was measuring something in terms of temperature, then switch my binning over to temperature, and then the temperature is reading in Kelvin. If I want to do everything every 5 millikelvin, I have to put X 0.005. All right, and then I want to go save this to save that program, and then it knows how to run on that. And the other thing, I want to do, I might want to do with that program is I might want to ramp the field up and down, and that's going to involve ramping that Keithley instrument or the gate control instrument. So if I look down here, there's a R command, which is sweep gate voltage on Keithley voltage source to some number of volts, optionally at a rate of some number of volts per hour. It's kind of strange units, but the other thing is that there is also, the other thing which is actually a little bit farther up here, is these M and N commands, which are maximum allowed gate voltage for the Keithley voltage port and minimum allowed gate voltage. So if we want to make sure, for example, that we don't exceed the 25 amps that our magnet can withstand, we might want to put in the program to put those bars on the Keithley to make sure we don't accidentally do something stupid. The default is, I think, plus or minus 1 volt. So if we need to go higher than that, we need to set these commands to make sure we go higher than that. So I don't know. We have to figure out what the conversion factors depends on our current source, because we're inputting from that Keithley to the current source. So, but let's say maximum 2 volts or something like that, and then I want to put the ramp command in. So I might want to ramp from 0. I want to ramp up to, let's say, 0.5 volts, and I want to do that in half an hour or whatever like that. So I want to go 1.0 volts per hour, so we get up to 0.5 volts. So we got to do a little bit of calculation to figure out, depending on how fast we want things to sweep, and what we need to figure out exactly what voltage we need to go up to get it to 10 millivolts. So the thing we need to do now is go balance your resistor on your measurement and figure out what our field parameters are and figure out how fast we want to sweep the field.
Okay.